Good morning, everyone. Thank you for attending the Modeling Mucosal Immunity, the summer school and symposium in computational immunology. We are pleased to have you here. I'm Josep Bassaganya, the director of the Center for Modeling Immunity to Enteric Pathogens and a professor of immunology at Virginia Tech. The center is part of the program funded by NIAID, Modeling Immunity for Biodefense. That includes a center at University of Rochester School of Medicine, a center at Mount Sinai School of Medicine and Yale University, Duke and Boston University, and our current center located at the Virginia Bioinformatics Institute at Virginia Tech. The focus of modeling immunity to enteric pathogens is to characterize the immunoregulatory mechanisms underlying immune responses to enteric pathogens. And the main focus, the proof of concept pathogens that we've examined are Helicobacter pylori, enterogregative E. coli, and Clostridium difficile. We combine experimental and computational approaches, and during this week we are very excited to give you a taste of the approaches that we have followed and others have followed to use immunological data to solve, to build mathematical and computational models and use mathematical approaches to solve immunological problems. We next validate those mathematical and computational models experimentally using data from animal models or human clinical experimentation. Throughout this week, you will be exposed to modeling intracellular signaling networks. For instance, today, you will be exposed to the concept of modeling immune responses through ordinary differential equations or agent-based modeling. We'll teach you how to build dynamic networks using Cell Designer, how to import those networks into one of our simulators developed by Virginia Bioinformatics Institute, complex pathway simulator, and we'll use CD4 T-cell differentiation and plasticity as a proof of concept for these approaches. On Tuesday, the focus is going to be on agent-based modeling, and we are going to show you how to use flow cytometry data and cytobank data to build and calibrate those agent-based models. We'll teach you about the suite of computational tools that Modeling Immunity to Enteric Pathogens has developed, called Enteric Immunity Simulator. We'll show you about an easy in silico experimentation, an easy stochastic differential equations, an easy high-performance computing. On Wednesday, we are going to teach you about connecting experimental data to computational modeling. How do you use big data and complex data sets in combination of smaller data sets to create new networks through network inference approaches, and how we can use those same data sets that we have utilized to build the network to help calibrate those dynamic models. We'll integrate theoretical approaches with data-driven approaches to modeling to enhance their predictive value. On Thursday, we are going to tackle the concept of multi-scale modeling, not only how we link across the scales, particularly intracellular scale, cellular scale, and tissue level scale with the proof of concept within the mucosal immune system, the main focus of modeling immunity to enteric pathogens. We are going to focus on the mucosal inductive sites, the mucosal effector sites, the lamina propria, the gastric lymph nodes, the mesenteric lymph nodes. And we are going to discuss the new directions of multi-scale modeling through hybrid computational approaches that integrate agent-based modeling and ordinary differential equations. On Friday, we are going to have the symposium that will be presenting not only mucosal immunology topics, but also topics related to vaccination and infection with respiratory pathogens. With that said, I would like to introduce our first speaker, Dave Bevan. He's the education lead of modeling immunity to enteric pathogens. and he's also a professor of biochemistry at Virginia Tech. He will provide the initial introduction on computational and mathematical model.